The LDAO Home team is pleased to welcome our guest speaker, Jeff Richardson, your presenter for Seeing the Fun and Game in Math. Before I introduce Jeff, however, I would like to thank our sponsors who've allowed us to make this a free event for you this evening. This webinar was made possible by a reaching out grant from the parents reaching out grant from the Ministry of Education. Please note that the views expressed in this webinar are the views of the presenter and do not necessarily reflect those of the Ministry of Education or the Learning Disabilities of Ontario. Okay, now the lawyers have been covered off. Let me introduce our speaker to you. Jeff Richardson has been in education for over 25 years. He's enjoyed various roles, including 4 years as a curriculum coordinator for the Hastings and Prince Edward District School Board, a 3-year secondment to Saganessa Demonstration School, a provincial school for students with learning disabilities, and most recently teaching grade 9 math to students with developmental delays. Jeff has led numerous workshops on assessment and evaluation, mathematics education and technology, and a recent focus on sessions exploring strategies on helping students with learning disabilities to be more successful in math. Jeff is also featured in an LD at School video on math, manipulative and technology. I welcome you, Jeff, this evening, and with that I will hand the cyber floor to you.
All right, thank you very much, Lawrence. And I hope you can see the screen there. I'm coming to you tonight from Belleville, just on the shore of North Ontario, or the North Shore of Lake Ontario. So I hope the audio is working okay. The agenda today is built on practice from my time at Saganassa Demonstration School here in Belleville, a provincial school for students with learning disabilities, where I had the chance to teach math to grade 9 students as well as students in the elementary program. And so in that role, I did a lot of research about what would work well for students with learning disabilities and just made my own observations. And one of the most powerful things I learned was the importance of students being able to attach a concept to numbers and all of the different procedures that they were going to learn, and to be able to visualize what they were working with. Students with learning disabilities often struggle with symbolic representations. So in other words, when they're reading, that would be letters and words. And in math, it's even more complicated because we have so many different symbols, numbers, and some of the visual representations like graphs and number lines and things like that. So I found that anytime we could make it not just about numbers and equations, but we could have a visual representation, then that really helped. And that's the main focus of this workshop. And just to make it generic so that hopefully everybody can get something out of it, the focus is really on number sense. And number sense to me means students having a real understanding of numbers. So being able to visualize what a number looks like and what a number means instead of just seeing it as a symbol on a page. And then I think they're able to work with it more easily. It helps with students with working memory difficulties, for instance, so that they can draw on a representation of numbers. So we'll be going through just that, visualizing numbers using 10 frames and then connecting that to addition, and then using a 100 chart as well for addition. We'll look at number lines, especially in terms of differences. We'll talk a little bit about estimating, which is an important tool for students to make sense of numbers. Eventually we'll get into multiplying, so kind of the beginning stages in multiplying, when to use it, and then how they can use a multiplication chart. And at the end, we'll connect it to measurement. And the workshop is called Seeing the Fun and Games in Math because I think the practice, having students with learning disabilities trying to memorize a lot of facts, for instance, isn't really going to work that well. It's going to be frustrating, I think, for a lot of those students. So instead, I've tried to connect to different games that I've played in the classroom with students and things that I have found successful in helping students engage with and improve their number sense. So just to get started, Lawrence did a great job with the introduction. So I think it's, I'd like to know a little bit more about you, the audience, just so I can tailor some of the messages. So we'll start our first poll. And what I'd really like to know is what grades are of most interest to you for your children. So In education, we call it primary, junior, intermediate, and secondary, but we'll break that down as grades 1 to 3, 4 to 6, 7 to 8, and 9 to 12. So if you can just submit that poll, and then we'll move along. And that way I just know what to emphasize a little bit more. Okay. While we're waiting, I'll just start moving along here. Okay, and I can see the results there. That's great. So one of the important things, I think, is when students, and even when I'm working with teachers and we start talking about math, we're going to start doing some math. And whenever I say that at a workshop, you can just feel anxiety in the room take place. And with students, it happens in classrooms sometimes. They get used to it eventually because they're exposed to it on a daily basis. But a lot of students do have math anxiety, and we know that that interferes with their ability to learn because it shuts down their brain a little bit. They're so busy being anxious and worried about math that they sometimes don't do as well as they could. Other students just believe they're not good at math, and it's almost like they've got permission for this because somebody in their life might have said, oh, it's okay, you know, your dad wasn't good at math, or I wasn't good at math, so you're probably not going to be good at math either. And so I just want to find out how people feel about math. It's so our second poll is going to be, which statement best describes your feelings about math? Do you love math and you feel like you're great at it? Do you kind of like math and you did okay in school? Do you like math but never did well at it? Or do you not like math but you feel like you're okay at it? Or do you hate math and it scares you? So if you can just take a second to answer that. And while you're answering it, I'm going to say that no matter how you feel about math, I believe it's really important to be positive with your children about math. And I know that when I went to school, the way math was taught, a lot of students couldn't learn in the way that it was taught because it was taught all symbolically. The teacher would show us a couple of examples, and we would have to memorize those examples and then try to answer the next questions using the procedure that the teacher showed us. And that for a lot of students wasn't great, especially students with LDs, because they're not great at memorizing and they never really made sense of the math that they were shown. So today, what we try to do in the classroom instead is let students explore a little bit more math and come at it with a more conceptual understanding so that they are able to do better at math. And so we really feel, I believe, that all students can do math the way it's taught now. We try to show them in as many different ways as possible so that they are able to all learn. So if we can be positive with students, that's half the battle right off the top, so they don't come in not feeling like they're good at math. Okay, so we're going to start the actual math part now. And the title on the slide says Developing Automaticity with Numbers. And that's kind of in a way, it's an edu-speak word there, educational jargon, automaticity. But I think the word kind of, hopefully it explains itself. We want students to become automatic with their concept of numbers and with operations, simple operations with numbers. So students with LDs often have working memory problems or processing speed problems. And so if they're having to stop and try to make sense of things as simple as numbers or simple addition questions, then their brain is getting taken up and they can't really be solving the problem at hand. So that's why we really want their ability to recognize and work with numbers to become much more fluent and automatic. So a tool that I use this with my grade 9 students this year in an essentials class, is the 10 frame. And the 10 frame is what you see on the slide in front of you. And like most manipulatives, we do want students to play around with them, but there's a very intentional way that students should use most manipulatives. So same with the 10 frame. When we fill the 10 frame, we always want to fill from the top row and then go down to the second row, and we always go left to right. And the 10 frame is divided into these 2 rows of 5 to replicate our hand. So the reason the number 10 is so important in our system is because we have 10 fingers, and that's what the entire system is built on, really. Tens, hundreds, thousands are all multiples of 10. So when I am representing the number here, the number 2, I didn't do one spot here and the second dot down below. Instead, I started building left to right across the top. Okay, and that's going to become important a little bit later on. So the first thing I want to do with students is be able to have them recognize numbers automatically without counting. So we want to get away from counting with a 10 frame And then eventually we also want to get away from counting on our fingers when we're doing addition. And that's where the automaticity comes in. So I want students to see this. And what we're starting to build is 10 facts, meaning things that add up to 10. So the first game we play with students when I'm doing this is I'll put this up on the whiteboard or the smartboard, and I'll have students say, I have 2, and then the I need part is how many more do I need to get 10? So ideally, we would just get them to recognize I need 10, but a lot of students don't recognize that right away, and they have to count the empty spots. So one tool that we want students to realize is they don't have to count all of the numbers on the bottom. This, a complete row, they should know is 5. So they don't have to count 1, 2, 3, all of these, and they should start counting up here 1, 2, 3, 4, 5. Instead, they should recognize this is 5 and then continue counting from there. So all they do is say 5, 6, 7, 8. I have 2, I need 8. So we would go through a number of examples like this until they become automatic with all of the different 10 facts. So from time to time in the presentation, I am going to be switching to a different tool that allows me to be a little bit more interactive. So you'll see me doing this, and probably the odd time I will get mixed up and end up in the wrong application. So just a little bit of patience as I do that. So I would have these set up as flashcards on my smartboard. So I would go through them as quickly as I can. Students would take turns. And I've made these available to you when the webinar is posted. I've made this a PDF, so you could print off these flashcards as well if that's going to be useful for your son or daughter. So I would want students to say, I have 6, I need 4. Okay. Next one, I have 3, I need 7. So just really going like that until it becomes automatic. I have 4, I need 6. The next step after that is that I want them to now think about this in terms of addition. So the I have, I need is really the same thing as recognizing the addition facts for adding up to 10. So instead of just saying I have 7, I need 3, then I'll get the students to say I have 7, I need 3, 7 plus 3 equals 10. And then we would go on to the next number and they would do the same thing. Again, practicing until it becomes automatic. So once we've got those mastered, and I feel like they've got a good feel for the 10 facts and what you can do with your son or daughter, again, now it's time to go to a game to practice that. So I had an app that there's kind of a game on my iPhone that made me think of this game. So I call it Tic Tac 10. So the goal of the game is to roll a dice, and every time you roll the dice, you have to mark the value on a space in the grid. So there's a little bit of strategy about where you're going to put those numbers. The goal is to get a row or a column to add up to 10. And if it does, then you get a point, and you can erase those rows and columns or those cells that you used to add up to 10, so you can use those cells again and keep the game going. And you keep going until you end up filling up the grid because there's no rows or columns that add to 10. And so we'll try to do a little demonstration here to see how that works. I've got a little interactive die here that I can roll. So I'm going to roll the dice. If it cooperates, there we go. And so my first roll is a 3. So I'm going to write a 3 somewhere on my grid, and then I roll the dice again. And I get another 3. So now I have to start thinking about what combinations I want. Where do I want to put this 3? So I'm going to decide to put it down below here, and we'll roll again. I get a 2. And you can start to ask at this point, let's see, if you've got a 3 and a 3 together, what do you want in order to complete a row of 10? So you can get students kind of, or your son or daughter, thinking ahead, and that will develop the number sense as well. So I rolled a 2, so now I'm going to put a 2, say, here. So now I know, oh, I'm looking for a 3 plus 2, that's 5. So I'm looking for a 5 here or a 4 here. So you get them to anticipate before they roll. I roll the next one. Oh, I got a 6. Well, I can still put that in the middle here, and that gives me quite a few more possibilities, and hopefully we'll get something. Okay, here's a 2. Ah, I've got a 6 plus a 2 in the column here, so if I put a 2 down here, that's going to give me 10. So I now have completed one column, so I get 1 point, and I now can erase these numbers and use them again. And some games go very quickly depending on how the dice roll is, and some games go on for quite a while, but the longer it goes on, the more practice they get. And sometimes they'll complete 2 rows with a row and a column, for instance, at the same time, if the numbers work out that way. So they get 2 points and get to erase a whole bunch of cells and keep the game going. And I always kept a high score about how many rows or columns students could get, and high scores seem to motivate kids to want to play again. So you can do that, or you can have a few different players playing at the same time on their own grids, everybody using the same dice roll. So then it comes down to strategy and being able to recognize. And we would do that, and it was amazing. Everybody had a different game board and got different scores. So it was kind of a fun game, and kids always like to play that one. Okay, so that was practicing our tens. Once we've got our 10 facts down, now we can move to what I call the near tens. And near tens, like the name implies, are things that add up to either 9 or 11. So if they know that 7 plus 3 is 10, then they should be able to do 7 plus 2, because that's 2 is 1 less than 3. So we didn't quite make it to 10, we made it to 9. And it might still be useful to show that with counters, depending on where your child's at with number sense. But now they're getting into a whole bunch of other facts that they can use for mental addition. The other one is 7 plus 4 then. So if we start with 7 and we add 4, oh, well, that's 1 more than 3. So what we can talk about with students is, well, we're breaking apart this 4 into 3 that they're going to use to complete the 10, and 1 more that is left over. Some students will really benefit from using 2 10 frames at this point, so that they can show the 3 going up to complete that first 10, and then the 1 more. And that connects to a more symbolic procedure that students will use, like adding up 7 plus 4, where they've got the 7 and then the 4 down below, and we get them to, all of a sudden they're using another column, the tens column. And this will remind them of why that's happening. We've got 1 in the tens column and then 1 in the ones column. And this will also connect to base 10 materials that they might have used in school. So once they've got these facts down now, so we've got our tens and we've practiced some with our near tens, now we can play another game. I don't know if it's really a game or just a practice thing, so using a deck of cards. So cards are great because the students can use the spots as counters. So again, it's a very visual representation. It'd be nice to have a set of cards, to be honest with you, that was printed like 10 frames. You'll see that it's not quite done that way, but it's still, they can still count the dots on the cards. So I use a game called Pile of Cards, and we try to get them to add up a whole bunch of numbers without writing anything down. So they're going to use their strategy of making 10 pairs in order to do that. And here's how it might look. So if I have this pile of cards, so I would deal out anywhere from 6 to 10 cards. I find works well with students, and then they're going to try to give you a total of this, again, without writing anything down. So I'm looking for 10 pairs. So I might recognize, for instance, oh, I've got 4 here and 6 here. So there's 1 10. Oh, and I've got 2 here and 8 here. So that's another 10. And then my other 2, this is kind of a near 10. If I have 7, I know I only need 3 to complete another 10. So I'm going to circle the 3 from my 5. 7 plus 3 is 10. I've got 2 left over, so now I see that I've got 1, 2, 3 complete 10, so that's 3 in the tens column, and 2 in the ones column. So my answer would be 32. So they were able to add that up without writing anything down, without using a calculator, and it's not too straining on working memory or processing speed. So again, I found students very successful using this kind of an activity, and it just, I know they're not really going to be adding up using playing cards all the time, but it leads to a mental model, and again, students can visualize what they're doing if they are adding up a group of numbers. So that was Pile of Cards. You might come up with a better name than that, but that worked for us. So now that we've got our tens and near 10 facts down, now we can start to add up bigger numbers. So again, once students know that they have 7 plus 3 is 10, just to keep using that example, now they should be able to do something like 27 plus 2 or 27 plus 3. They might use 2 10 frames. And what you'll see on this card is I've got extra counters up top here. So when I'm using 10 frames, I'm using counters to fill in the grids. So I've got 2 extra counters up here to represent my 10s. So in red, you'll see the number 27 represented. These are the 2 10s for 20. And then the 7 along the 10 frame. So if I'm doing 27 plus 2, students will see, oh, well, that gets me to 29. 27 plus 3, well, that completes another 10. So now I would have 3 complete 10s, that's 30. And they can even do 27 plus 4. Again, visualizing this I find really helps them. So that 4, they break down into 3 and 1 again. So the 3 completes the 10, so we've now got 3 10s, and I've got 1 left over. So 27 plus 4 is 31. And you wouldn't believe how many students I have in grade 9 that I have to, if I was giving them 7 plus 4 as a pattern, for instance, they would have to get the calculator out, let alone 27 plus 4. As soon as the numbers get big, they seem to shut down and don't even think that they can answer it. But if they use a tool like this, I think they'll understand better, and they will be able to answer those questions, so they don't have to take all that time to go to the calculator, which again derails their working memory. So let's do another example of that in the interactive tool here. So if I wanted to do 36 plus 25, I've got a section on my 10 frame where I'm going to show completed 10. So in red already, I'm showing 36. So I've got my 3 completed 10s down at the bottom here, and then my 6 at the top. So 36. And now I need to add 25. So what I'm going to do is, well, I already know that I've got 2 10s that I'm adding in for 25, so I'm going to use a different color just to illustrate it. So there's my 20, and now I need to add 5 more. So I'm going to go 1, 2, 3, 4. Oh, that's what I needed. I had 6, I needed 4 to complete the 10, and then I've got 1 left over. And like I said, it depends on the student's number sense, how quickly they'll be able to transition from doing this with a 10 frame to being able to do it without. So their answer here, they've got 5 completed 10s that they're already showing at the bottom. They've got another completed 10 here, so that's 6 completed 10s, and then they've got the 1 left over in the new 10 frame, so that would be 61. So again, able to do that without talking about things like carrying over. Instead, we are completing 10s, which will lead to that procedure later on when they do see it symbolically in the classroom. All right, so once they've got that, here's another game now that they've got all their different addition skills, so getting into some bigger numbers now, and it's a game we called Risk. It's another dice game. This time we roll 2 dice beforehand, and there are 4 rounds. The letters really don't mean anything. It's just like round 1, round 2, round 3, round 4, and players can score points in each round. But it's called Risk because the risk is, as you roll the dice, whenever a 1 comes out that in either of the dice, then that wipes out the scores from that round. So if you haven't already decided to play it safe and take your score, then you would get a 0 for that round. So on the scorecard I'm showing you right now, John looks like he played it safe after the first roll of 7. Paula stayed in, and they must have rolled another 6 to get up to 13 for that round. So she took her 13. The last 2, Mai and Anna, decided to risk it and go for a 3rd roll, and it looks like that's when a 1 came up on one of the dice, so they ended up getting 0. So just to make it a little more clear, this is what it might look like. And this was probably my students' favorite game this past year. And the good thing is they're all practicing their addition. So whoever rolls the dice, for instance, is responsible for adding up the numbers. So 6 plus 2, so they would get 8. So we will record the 8 for that roll. And let's say the student decides he's going to play it safe. So he takes his 8, whereas Sample, gotta love those sample names I've got there, student and Sample, very funny. Sample decides he's going to risk it again. So he rolls the dice and gets, 5 plus 5, there's a double that we're going to talk about in a minute. So he writes down that you've got another 10 here. So now they have to keep adding up to see, well, what's this round worth right now? Well, now it's worth 18. So let's suppose Sample is feeling really lucky. He's going for the high score, so he wants to roll again. And let's keep pretending until, that'd be a nice roll. Okay, so let's suppose this was the roll. Oh, he got a 1. So that means that all of this is wiped out, and instead Sample would get a 0. Okay, and then we would go on to the next round. So we could erase these, and we start all over again for the next round. And when they get to the end, then they also have to add up to see what their total score was. So there's addition all over the place. Within the roll, adding the dice, and then adding up the total. So it's turned up being a really good practice, and it also connected to probability in math. What's the probability of rolling a 1? And so talking about how it's kind of a 1 in 3 chance connects to some of the probability stuff they'll do in school as well. Okay, so I should say that this slide is really busy and I didn't read everything, but because these slides will be available, all the rules are explained there, so hopefully you can make sense of it if you come back to this slide to see it. So on a lot of the game slides, I won't go through and read everything, I'll explain it, and then you can come back and see all of the information on the slide. Okay, we're going to switch gears a little bit. We've talked a lot about different addition strategies, but one thing I'll find is that students, even when they have strategies, will make some mistakes. And so what we want to do is give students a tool to be able to recognize when they're making a mistake, or to give them a tool to make a better guess, for lack of a better word, if they are adding up 2 numbers. So one thing you can do is use an addition chart. And there's lots of different charts, addition charts, written in 2 different ways, either from 0 to 99 or from 1 to 100. Sorry, those are 100 charts. Or you can use an addition chart or a multiplication chart. And there's some interactive ones that are available on the Mathies website that I'll show you in just a moment. But what I'm showing on the slide right now is just a small corner of an addition chart. Instead of going all the way up to 10 plus 10, this is just a corner going up to 5 plus 5, so we can see the numbers a little bit better. And I want students to recognize patterns, so I would just give them an addition chart and have them recognize all the patterns. And they might say, oh, well, the same number appears in a diagonal every time, and we can talk about why that happens. Another thing that I want them to focus on is odd and even. I think that's a really useful tool for being able to reflect on your answers. So you'll want to make sure that your child has a good understanding of what odd and even means, and what numbers are odd and what numbers are even. So that becomes automatic as well. And then I've highlighted on this chart all of the even answers. So 2, 4, 6, and so on. 4, 6 in the next row, etc. And I might ask, well, how do we end up with an even number? What 2 numbers add up to give us an even number? And they'll see, oh, well, here it's 1 plus 1 to give me 2, and here it was 3 plus 1 to give me 4. So, oh, those are both odd numbers. So it looks like when I'm adding up 2 odd numbers, I get an even number. Okay. And then down in the next row, it's a little bit different. It's a 2 plus 2 for a 4, and a 2 plus 4 for 6. Oh, those are both even numbers. And then they'll want to go down and check to make sure that always works. And so it turns out, and you'll want them to come up with these rules, but an odd plus an odd is an even, and an even plus an even is an even. So the only way we can add 2 numbers together and get an odd number is if it's 1 odd number and 1 even number, and it doesn't matter which order we add them in. So that's another thing they can recognize from this chart. The school word, the education word for this is the commutative property, meaning commute to mean to move. It doesn't matter what order we do it in. We can change the order, and we still get the same answer. So they'll see that with the number 5, for instance. So 2 plus 3 is 5, same as 3 plus 2 is 5. And as adults, that seems pretty obvious, but it's something that students need to be made aware of, and it's really powerful if they can uncover it themselves by looking at an addition chart. So, like I said, there's these tools available on the Mathies website. And the Mathies website is an awesome website. It's got lots of different tools and resources on it, and including a lot of virtual manipulatives. So part of the seminar is about connecting to what students are doing in school. So not all of us have all of the manipulatives that our students might be using at school, but everybody can go to mathies.ca if you have internet and use some of the tools. So I was just wondering how familiar people are with the Mathies website. So this is going to be our next poll. So how familiar are you? Do you use it a lot? Have you tried it? You've heard of it and you've tried it a little bit, or have you never heard of it? So we can just take a second to answer that poll, and I'll just quickly show you what the Mathies website looks like, what it has. Okay, so it looks like most people, almost half the people haven't heard of it, but another half have used it a little bit, so that's great. So the The Matthews website, I'll just really quickly show you here. If you go across the menu here, you'll see that there's home support, so those extra things you can do at home. There's a bunch of activities, learning tools, and games. So I've gone to the learning tools section here. So these are where you might see some of the virtual manipulatives. There's even calculators and things, but number lines, fraction rods and decimal rods that students might use in school. A money kit so you can play around with money without having to, let your kids have access to your actual money just to work on their number sense. And then this is the one I was just talking about, the number charts. So you'll see that there's hundreds charts, multiplication tables, and addition charts. Okay, so really worth checking out the Matthews website. Okay, so let's have a look at another use of the hundreds web chart. This is kind of a neat thing. So I'm going to flip to my interactive tool for this. So here's a hundreds chart, and one neat pattern that I was showing on the other slide there is if we wanted to just work on some really simple arithmetic, so kind of our things that add up to just one-digit numbers. Let's take the number 6, for instance. Anytime, if you look at the diagonal going up and right towards it, the 2 digits in all of these numbers add up to 6. So 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5, all equals 6. So if you want, and your child needs practice just with those becoming automatic, then having a hundreds chart printed off and working on some of these skills can be really handy. So you can ask your son or daughter, hey, what's 4 plus 2? They find 4 plus 2, and then they work their way up to number 6. And it's just a way to, again, avoid counting, but recognizing some patterns. And another neat thing, if we look the other way, so going down and to the right, now we have differences. So the difference between 7 and 1, 8 and 2, 9 and 3 is all 6 again. So kind of a neat pattern on a hundreds chart that a lot of people aren't aware of. Way we're going to use it now is to do a little bit of addition. So if I wanted to add up, say, 32 plus 41, so we were doing this with near tens, but now we can do it with any 2-digit numbers that we want. And again, it's a very visual approach to addition. So because the number chart is in rows of 10, every time I move down another row, I'm really adding another 10 to my number. And anytime I just move 1 to the right, that's adding 1. So we can use that to do 32 plus 41 as an example. So if I do 32 and I want to add 41, I'm going to start by adding the ones. I've seen it done both ways, but I kind of like this because it connects to the procedure they're going to do later. So I'm going to add 1 to get to 33, and then I'm going to add 40. So I move down 4 rows, 10, 20, 30, 40, and I get to 73. So 32 plus 41, 73, and here's a very visual way of seeing that. Let's do a slightly harder one, 28 plus 43. So again, I'm going to start at 28, and I'm now going to add in my 43. I'm going to start with my 1. So I have to go 3 to the right, 1, 2, 3. So I've finished at 10. I've gone down to the next tens. And now I have to add in my 4 tens. So I'm going to go down 4 more, 1, 2, 3, 4. So 10, 20, 30, 40, and I end up with 71 as my answer. So this is an important concept that we will teach students when they're doing more of an algorithm or more of a procedure. Sometimes this is the only way addition is taught, and it's very symbolic. So students really don't understand when the teacher says, okay, do 8 plus 3, that's 11. So you do the 1 and you carry 1. Well, what does that really mean? We're not carrying 1, we've completed a 10. And if students have the visual from the hundreds chart, this will make sense. And I think it would be kind of nice if we actually wrote it as, that's supposed to be a 10 right there, so 0. It's hard to write accurately on this computer, but so we've got an extra 1 now. So 10 plus 20 is 30. Add another 40, that's our 70. So that's what that 7, where the 7 comes in. We usually just say 1 plus 2 plus 4 is 7, but it's really 1 10 plus 2 tens plus 4 tens is 7 tens. So I would rather talk about it like that so that students are reminded of the place value. Okay, moving right along. So lots of good uses for addition charts as well. Now we've kind of given students tools to be able to add any 2-digit numbers and 1-digit numbers. So I would say having these tools available is really useful. So 10 frames, hundreds charts, an addition chart, whatever the student needs to help them. Calculators are okay too for various things, but if we're really working on addition, I would rather they don't use a calculator for the practice. If they're just doing problem solving, then a calculator can be great. Here's a game that I used to play as a kid with my family, actually, when I was a kid, and I've used it in classroom now because there's so much addition and good practice with it. So the object of this game is to, everybody adds a card to the middle, and you keep a running total going, but you may not go past 99. That's the name of the game. If you go past 99, you lose that hand, and we called it you lose a life. And everybody starts the game with 3 lives. If you lose all 3, then you lose the game. So the way to keep yourself alive is to collect special cards. So they're the ones that are pictured there, the 2, the 9, the Jack, and the Queen. So you might be, somebody puts down a 6, and then somebody else puts down a 10, so now the score is at 16, and so on and so it builds. And when you get into the 90s, all of a sudden you might not be able to put down a 7 because that would put you over 99. So instead, what you might want to do is have a 2. That doesn't add to the score, so that just changes direction. So if you're at 98 or 99 even, and you put a 2 down, it stays at 98 or 99, but just changes direction, so you stay alive, and it can be a fun way to get the person sitting on your other side. A 9 automatically makes the score to go to 99, so you can play that as the first card of the round, and then you might catch somebody before they've had a chance to collect the special card, so that's kind of a fun gamble to play as to whether you want to put the 9 down. A Jack is like adding 0, so it's one of those special cards, so it's like +0, so if you're at 99, you can still play a Jack. And a Queen also keeps you alive, but it gives the next player a chance too because it subtracts 10. So if you're at 99 and you play a Queen, it goes to 89, and then the next person is going to be able to play any card as well. So it's probably the nicest of the special cards for your other people in the game. The King adds 10 just like any other game. And so, like I said, getting students or children to practice their addition as the game goes can be really valuable. So let's switch gears a little bit, and we're going to talk a little bit about subtraction. We don't have a whole lot of time, but we'll quickly mention subtraction. You can use a 10 frame and number lines as well. So I'm showing on the 10 frame well, I guess the first thing you want to do, the first connection is to show students that 2 + 7 is 9 is very similar to 9 - 7 is 2. We call those fact families, and that also means 9 - 2 is 7. So we can look at subtraction as the difference between two numbers. So really what we can do is count up from one number to the other number and see what the difference was when we counted. So to show 9 - 7, I'm going to start with the number I'm subtracting, the 7, the smaller number, and I need to count up to 9 to see what the difference was. So I went 8, 9, oh, that was 2, so the answer is 2. Okay, so that's a counting up approach. It's the same approach that you might use if you're giving change, for instance. If you're doing $5 and the product came to $4.50 and you have to count up, what's the difference? You're doing subtraction by counting up. So you start at $4.50 and count up to $5. A number line can also be a great way to do this. The Matthews website has great number lines. So we'll just have a look at how you might use a number line for this. So if I wanted to do, say, 12 subtract 5, I'm going to start at 5, and I need to get to 12, so I'm going to count up the difference. So 1, 2, 3, 4, 5, 6, 7. So 12 subtract 5 is 7. And the Matthews tool lets you do this just by dragging from one dot to the next. That's what you can see down at the bottom of this slide. That's what the number line looks like, the interactive one on Matthews.ca. So that's really worth checking out as well. And I think number lines are awesome because, again, it's a visual representation of where the numbers are relative to other numbers, and they're great for fractions and decimals too. And especially when you get into integers, for those of you that have older children in grade 7, 8 where they're doing integers, they're fantastic for that. And on the Matthews website, you can make them vertical or horizontal. So to practice some subtraction, some people have played a game called Snap. So I play subtraction Snap. So 2 players, they've got a deck. I would take the face cards out because they just become confusing. Deal all the cards out to players. They've each got a stack in front of them with the same number of cards to start with, and each player simply flips a card, and then the first to shout out the difference between their 2 cards wins both of those cards. And once you've gone through all your cards, then you reshuffle the cards that you just won and keep going until one player has won all of the cards. If I often found with students with learning disabilities, because processing speed is such an issue, sometimes timed things didn't work too well. So instead, you can just have players take turns, or if you're only working on this with one child, then it can just be a practice thing for one child, or you can just give them a certain amount of time to try to get it that's appropriate for that student. All right. So that's all we'll talk about for subtraction, just due to time constraints, but we'll switch gears again and talk a little bit about estimating. I think estimating is a really underutilized skill in math. I would always encourage students to make an estimate before they actually do a calculation, and that way they're making sense of the problem and making sense of the numbers that they're dealing with. So just in the real world at home, what you can do to estimate is all sorts of different estimates. For instance, estimating totals if you go out shopping, if you're buying a few things, or if you go to a restaurant, getting students to, or your children to estimate the total. You can estimate time, so how long has it been since we left the house, or how long does it usually take us to do this, or how long, so getting students used to time. You can do it with distance, so how far do you think it is to, from here to, there, wherever you're going, from here to the store. You can, a really powerful one is just when you're walking, estimate how many steps is it going to be to the corner, or whatever it is. Estimating money, so if you splash out a whole bunch of money, like this, for instance, and then trying to get students not to calculate it, but to actually do an estimate first and then calculate it. And that takes us to our next game called Over-Under. So it's a game where no matter what you're dealing with, one person has to make an estimate as quickly as they can, and then the second person has to say whether it's over or under. Again, they have to do it without counting, ideally. So time is kind of the essence here. So in this case, if we threw these coins down on the table, or if you went to the mathies.ca website and used their coin tool and generated this picture, one player might estimate, I think that looks like about, 82 cents. And the other person has to say if it's over or under. And that person, if it is over 82 cents, they would win. If it was under 82 cents, then the person making the estimate would win. If it was exactly 82 cents, then the person doing the estimate could win 2 points. And it's kind of a fun thing, so you can do it for a whole bunch of different things. Out for a walk, how many steps is it going to take to get to here? One person makes a guess, the other person says over or under, and get your points that way. Estimating prices of things, even, to get students better with sense of money, that kind of thing. Time, all sorts of stuff. So just looking for any places in the real world where you can make those kinds of estimates. It could be the number of ceiling tiles in a room, something like that. Okay, we're going to switch gears again now and get into multiplication. So we'll do a really quick introduction to multiplication. And the cornerstone of multiplication is doubling. People in general are good at doubling, is what the research shows. What I've found is that students are good at doubling the numbers 1 to 5, but then as soon as the numbers get a little bit bigger, that's where they struggle. Here's where our 10 frame can come in handy. So in the example I've got shown here, I talk about partners. So I talk about how most students can double 2. For whatever reason, they just know that 2 doubled is 4, but if they had to double 7, they're not so good at that. But if they can see it as a 10 frame and see that 7 is 5 plus 2, and we know that when we double 5, that's 10, so that just completes our 10, and then the 2 doubled is another 4, so that's 14. So you can see why 2 and 7 are partners. They both end in 4. One is 4 and the other is 10 plus 4. So once you introduce this concept to students, you might ask them, well, what are some of the other partners? And so hopefully they'll say, well, 3 and 8 would be partners, 1 and 6 would be partners, that kind of thing. And then if they can double the smaller number, they should be able to double the larger number. And you really need to work on doubles with students, and you're basically doing the 2 times table at this point. So you can talk about, that can be your introduction into multiplication. Well, if we add 2 of the same thing, that's the same thing as multiplying by how many there are. So in this case, multiplying by 2. And another addition fact that it can help with is near doubles. Just like we had near tens, now we've got near doubles. So if they can eventually do 6 plus 6, recognizing that as 12, then they can do 7 plus 6. Oh, that's just 1. That's a near double. It's 1 more than 6 plus 6, so it's got to be 13. So it can add to both addition and multiplication skill. Once they get good at their doubles, then you can play double snap. And it's same idea as the other snap, except in this case, all the cards would stay in the middle, and players would just take turns flipping one card, and whoever can give the double of that card wins the card, and whoever has the most cards at the end of the deck would win. or you can just do this, like I said, as practice with your child. So another thing about multiplication is recognizing when to use multiplication. So anytime you're out and you buy several things of the same cost, you can explain how that might be an example of when to use multiplication. If you're counting money and you've got a whole bunch of the same coin, instead of using an addition model, we can use multiplication. You might do it for determining the number of bricks in a wall or tiles on a floor or a ceiling, that kind of thing. And here's a fancy word we'll use in school called arrays. So you can introduce that at home as well. And arrays are all pictured, things like pictured at the right. A muffin tray is an array. Anywhere where you've got a repeated row a certain number of times. So in this case, say rows of 3 repeated 4 times, that's an array. It could be the little nibs on a Lego piece. And there's all sorts of different arrays. So we can use multiplication to figure out the total number here. And again, just introducing that as an efficient way of doing repeated additions. So instead of 3 plus 3 plus 3 plus 3, that's 3 times 4. So students get a feel for when they can use multiplication. So then that means that students need all of their multiplication facts. We've introduced doubling. So memorizing an entire multiplication table like the one pictured can be very daunting for students and for any student, let alone a student with an LD. So instead, I think it's important that students have strategies for all of the different multiplication tools. And so a document will be provided that shows the different strategies. So we'll just really quickly talk about those. We just said the 2 times table is like doubling. So 4 times table is like a double-double because you just have to double twice. So 4 times 6 is like 6 doubled and then doubled again. So 6 doubled is 12. Double that again, that's 24. So now they've got a strategy they can use for 4 times table. The 3 times table, that's like a double plus another. So 3 times 4, for instance, is like 4 doubled, which is 8, plus 1 more 4, which is 12. So introducing all of these strategies, so what I would suggest is working on one of the times tables per week and really practicing that until they get it down. And again, depending on your child, doing all the way up to 10 might be too much. So you might just start with the red square, just go up to 5 with 1, 2, 3, 4, and 5 times table, and then add in up to 10 after that. And you can show students that the bottom orange square is the same as the top orange square. So they're not memorizing all of these because they're repeated, because 7 times 6 is the same as 6 times 7, so that they don't get too overwhelmed with what they're doing. So the last thing we'll talk about is just a visual way to do 2-digit multiplication. This one gets a bit of attention sometimes because we were all taught multiplication the old way where we'd have the 14 on top of the 12 and there's all this carrying numbers and all that stuff and making sure you line them up. So I think a much more valuable way to do 2-digit multiplication is a visual model. They might start it hopefully with base 10 blocks, which they're familiar with in school. So 14 times 12. Base 10 materials are these yellow 10 rods, and the unit tiles are worth 1. So 14 would look like this: 10 plus 4. 12 is 10 plus 2 down the side. And so to do the multiplication, it's almost like you could say you have a 14-meter field by a 12-meter field. What's the total area of the field? And they break it down into chunks. So 10 times 10, they should know is 100. 10 times 4 is 4 tens, so that's 40. And then we come down here and do 2 times 10. That gives us our 20 here, 2 tens. And then 2 times 4 is 8. And they've got a very visual way of seeing the answer now. It's 100. 40 plus 20, well, that's 6 tens. That's 68, 168. So it connects to measurement and reminding students that they can always use area as a model for multiplication. It's probably the best model because it works for fractions and everything. At home, you probably don't have base 10 materials. I do, but I'm a math geek. So most people wouldn't. So instead, now we can transition to drawing it out. So this is the exact same thing, but drawn out. And it reminds students that if they have 10 tens, then you can trade that in for an extra 100. So that's why the answer here is 100, 200. These are 10 tens. That makes 300, and so on. And the same thing with ones, making a group of 10. And then eventually, drawing some of these out, like doing 78 times 89 this way, would be a lot of drawing for your individual dots there. 9 times 8, 9 rows of 8 dots. That's kind of a pain to do. So instead, we do eventually want to get to using numbers. So in school, they might learn something called the box method. So it connects directly to that visual model. But if the teacher doesn't do the visual model first, that's where you can step in and recognize how to do that visually. So here we're doing 14 times 27, and we're breaking up the numbers: 14 into 10 plus 4, 27 into 20 plus 7, and then they get their areas in the middle, and then they have to add them up. And they can use different tools, so you'll have access to this slide. We're almost out of time, but they might keep track of how many hundreds they have, how many tens they have, and how many ones they have in columns in order to be able to add it up if they have working memory problems especially. But this kind of strategy really lends itself well to mental math as well. And this also leads us to our final game. So I call it the area game. So students start with a 10 by 10 grid, and again, we roll the dice. So in this case, we might roll, let's say, a 3 and a 5, and so the students have to represent a 3 by 5 rectangle on their grid. Then you roll again, and the goal is to fill up as much of the grid as you can, and then until you eventually roll numbers that you can't fit in somewhere. So you have to be strategic about how you place your rectangle so you leave yourself the best chance of being able to put one down. And again, we kept a high score for this, and students always wanted to play this game. You can also connect it to percentage, because we have 100. If you have a 10 by 10 grid, mine's actually only 9 by 9 on the slide, but if you do have a proper 10 by 10 grid, then you've got 100 possible squares. So if the student was able to cover up, like in this example, 47, then you can talk about how that's 47%. And in this case, the game was over because there was nowhere to fit a 6 by 3. Different students, though, if you're playing with the same dice roll on different grids, each student has their own grid, or each child in the game has their own grid, then depending on how you lay it out, some kids will get out sooner than other kids, depending on the strategy that they've used. A couple of other considerations. I always find that using a whiteboard is really powerful for kids. They can erase much more easily than they can with paper and pencil, and they're more willing to try things because they don't feel like they're making mistakes. It also connects to a strategy that a lot of schools are using, where we're using groups on vertical whiteboards, so whiteboards mounted on walls to solve problems instead of having kids work individually. And then the final thing I'll talk about is capturing learning. Because we're doing a lot of visual work and using manipulatives and tools a lot, it's great if students can capture pictures of what they're doing, and students with LDs often don't like to write down a lot of words, but they don't mind speaking. And so an awesome app, if you haven't seen it, is Book Creator. It's a paid app on an iPad. You have to buy it for about $6, I think, but there is now, just as of the last year, a free website that they can go to, app.bookcreator.com, and they can very easily add in pictures. They can annotate it with text or a pen tool to draw around things, and I found really useful is they can record their voice. So this could be a great way for students to summarize their learning once they get home. What did you do at school today? Well, draw a picture and do a voice note. And they can have like a book for each unit that they've been working on at school. It's an awesome tool. And finally, some resources that are useful. We've talked about Mathies, we've talked about Book Creator, but another one that the ministry has provided is EduGains, and here's the link to it. There's all sorts of home supports available for students, so extra games that you can do, different activities, the curriculum, only for grades 1 to 3 right now, but just so you know what's going on at school, they've got a visual curriculum and other things like that, so it is definitely worth exploring as well. And that is the end of the formal presentation. Let's see, we've only got a few minutes left for questions, so went a little bit over time there. So I'll turn it back to, I don't know if it's Lawrence that's going to be taking any questions that people might have.
Thanks, Jeff. Sorry about that. I left my mute button on for a second. Thank you so much. You knew math could be so much fun. So we are running a little short of time, folks, but we do want to offer you the ability to answer any questions that may come up. So, Jeff, I've got one to start with here. For those of you that may want to ask a question, you can use your box to come through to me. The first question, I guess, is about frequency. So there's a lot of games here, a lot of exercises. Any guide to how often you should be doing this with your child?
Can you still hear me okay?
Yes, we can.
Okay. I would say almost daily, but if you're working I would chunk the skills. So if you're working on addition, for instance, then really focus on addition and just try to do it for 10 or 15 minutes each day. And it can be partly a drill and partly a game. So making sure that they understand the concept or whatever tool you're hoping that they'll use, whether it's a 100 chart or an addition chart, teaching them how to use that addition chart, and then playing the game where they can use that tool. But I think, you know, 5 times a week or something while you're working on that is the way that it's really going to sink in and become much more automatic. If they see it much more sporadically than that, especially if the student has memory problems, then I think it's harder for it to reach that level of automaticity that we're looking for, so that it frees up their processing for other things.
Okay, perfect. Second question, Jeff, you talked a little bit about not always having a calculator present, and I just wanted to ask you if you could add a bit of clarity about when it's good and when it's not so good, just how you differentiate the use of the calculator.
What I have found, and there's some research that backs this up, is that using a calculator can actually help students develop number sense. So if the student is doing a problem, say, on area, so the point of the problem is to solve a situation, so to solve a problem involving area, I think they should be using a calculator as needed for that, so that they're not getting bogged down in the calculations. Whenever the intent, though, is to work on an operation, and a different learning tool, then I would take away the calculator and have them use a different learning tool that maybe is a little bit more visual. Now, there are times when they can use the calculator to recognize patterns as well. So some calculators, for instance, you can go 4 + 4 = and then keep hitting the equals button. So if a student has a hard time, say, with counting by 4s, which is an important step in learning your multiplication table, you can use the calculator as a learning tool as well. So if the focus is on operations, typically the rule of thumb I would give is not to use a calculator. If the problem solving is, you know, where the operation is sort of incidental or just necessary to solve that problem, then I would let them use a calculator because it's the most efficient way for them to get their answer.
Okay, perfect. All right, well, in the absence of other questions, folks, we're going to call an end to our Q&A and make sure we honor your time and finish on time tonight. Just a slide I've currently put up, LD at Home recently launched a new video and a parent resource kit around building math skills at home. This webinar is kind of a complementary piece to that. So there is information and resources there to take some of this learning and also some other new documents as well. Make sure you check that website out. It's ldathome.ca, and when you get there, look under the What's New tab on the homepage. We'll also be sending a direct link out when you get the follow-up emails to this webinar. So with that, on behalf of the LD at Home team, I want to thank you again, Jeff, for your presentation. Lots for us all to chew on, I think, as parents helping our kids with math. And to those of you that have joined us tonight, thank you. We know that time is always short and schedules are busy, and so we hope that you got some value and that you'll give us your feedback in due course on the survey. With that, I hope that now you're going to have more fun with math going forward and help the student in your life to get a greater success and certainly cope with any math anxiety they may be currently struggling with. Until the next time, on behalf of all the team here, I wish you a very good evening.